Hello, ladies and gentlemen. Today we're going to be talking about solving absolute value functions. So remember, an absolute value function f of x equals x always measures the distance from x and is always positive. Now, some of you know this is just always turns a negative into a positive. Um, Essentially, yes, but that is not the correct definition. If you put that, you could be marked wrong on the test. So measures the distance from x is the technical term I'm looking for. All right, so steps to solving absolute value functions. So if we follow these steps, it'll work every single time, all right? As long as you know how to solve your linear equations and whatnot. So first step is to isolate the absolute value on one side of the equation. So let me get my pen. So you want this just like this. Now it can be x plus 3 equals a. Or you can have absolute value, another combination of x plus 2 absolute value of a plus xb, where x is the actual variable x and b is just another number, just like a is. And we'll see some examples like that. So step 2, is the number on the other side of the equation negative? Now let's look at that. If you get the absolute value isolated, and you still have a negative on the other side, well then obviously there can be no solution. If I have the absolute value of x equals negative 3, is there anything I can plug into here to get negative 3? No, if I plug in a negative 3 absolute value, what do I get? I get a 3, and that is not the same. So that's what I mean by that. That's another way of writing no solution. Boom. All right, if you answered yes, then the equation has no solution. If you answered no, then go to step 3. Write the two equations without absolute values. The first equation will be set in typical. So basically what we're going to do here is we have this. This is what we get down to, absolute value of x equals a. Well, we have to know that x equals a or x equals negative a. For example, say we have the absolute value of x equals 3. Now, x can equal a, so x equals 3. But if we put in x can also equal negative 3, because if we put in a negative 3, absolute value of negative 3 still gives us a 3 as an answer. 4, solve the two equations, and then 5, check your answers. Now we're getting to the part of math where you have to check your answers. It's very imperative that you check them. We'll see an example later on to where you get an answer that looks reasonable. However, when you plug it back in, it does not work. You have to check your answers. If you do not check your answers and I do not see your work, things will be marked wrong. So let's do an actual example here. So I have absolute value of x plus 2 equals 5. Now isolate the absolute value on one side of the equation. Is that already done? Yes. My absolute value is by itself. I have no numbers adding, subtracting, multiplying, or dividing to it. So it is isolated. Step 2. Is the number on the other side of the equation negative? Nope. It is positive. Positive 5 here. So we're going to skip down to step 3. Now we're going to split it. So we drop our absolute values now, and now I have just x plus 2 equals 5. And then I'll also have an x plus 2 equals negative 5. So everything on your right-hand side that's not absolute value, you're going to have one positive side and one negative side. This, if you notice, stays the same. X plus 2 is just x plus 2. We just drop the bars. And now we go ahead and can solve each side as we would. So x equals 3 and minus 2 minus 2. X equals negative 7. If we plug that back in, absolute value of x plus 2 equals 5. Let's plug in 3. 3 plus 2 equals 5. 3 plus 2 is 5. Absolute value of 5 is 5. Check. Let's check the other one. Absolute value of negative 7 plus 2 is supposed to equal 5. Negative 7 plus 2 is negative 5. Absolute value. Absolute value of negative 5 is 5. That equals 5. Check. So yes, you have to show all your work just like this until you get something like that. So this one works. Let's see another example. So this one, first step is to isolate. Is it isolated? Yes, it is. I have nothing adding, subtracting, multiplying, or dividing to it. So now we have to go ahead and split our absolute value. So again, go ahead and do your tree. I have x plus 2 equals 7. And I have x plus 2 equals what? Right, negative 7. All right, so we'll go ahead and solve our left side first. So subtract 2, x equals 5. And then if I look at my right-hand side, I have minus 2, x equals negative 9. And then we have to check our answers again. So the check. So first we're going to check for x equals 5. I have absolute value of 5 plus 2, absolute value equals 7. Absolute value of 7 equals 7. True. So then we're going to also check, we're going to check up here. Check for x equals negative 9. So again, plug it back in. Absolute value of negative 9 plus 2 equals 7. Absolute value of negative 7 equals 7. And so 7 equals 7. Check. They both work. We're good to move on. And let's see what this looks like graphically. Boom, boom, boom. All right, so here is our absolute value here. And we notice their transformation, right? We just did transformations. We have x plus 2 on our absolute value. So where do we shift? Left 2. And then equals 7. Now 7 can also be looked at as just a line, right? Y equals 7. So if that's the case, here's 7. And we can see it crosses right here on negative 9 and right here at 5. And that's what it would look like graphically. So our solutions, when we find the solution to something like this, we're looking to where our two lines on the graph intersect. So two answers, two intersection points. All right, something a little bit more complicated here. We have something multiplied to our absolute value. So in this case, our absolute value is not by itself yet. And I have to get rid of my negative 2. Now my negative 2 is being multiplied against it, so to get rid of it, I'm going to divide both sides by negative 2. So these will cancel out right here. Give me an absolute value of 3x plus 3 equals 6 divided by negative 2 is negative 3. Now, what's my next step? You're right. I do not have one. I have an absolute value equals a negative number. And if we remember our rule, rule number 2, if you isolate the absolute value and you have a negative number on the other side, what do you get? A big old fat no solution. And that will work. You could just put that on any worksheet you do or any work for me that you do, and I'll accept that as no solution. All right, solving absolute values again. So here's another one. This time we have an x on the other side, and we're going to see what happens with this. However, don't fear, it's pretty much the same exact way that we solve all the other absolute values. So first, I need to isolate my absolute value here. I'm being multiplied by 2, so I'm going to divide both sides by 2. Cancel out here. And then I get an absolute value of 3x minus 6 equals, this will cancel here and give me a 2, so I get a 2x. And now we split. So, boom, boom. My absolute value is isolated. There's nothing else I can do to isolate it. This is just another term. It's a line. So we're going to see where these bad boys meet. So I have 3x minus 6 equals 2x. And then I have 3x minus 6 equals negative 2x. And let's go ahead and solve our left-hand side. I like to keep all my variables positive, so I subtract 2x and then add 6 to this side. So these will cancel, these will cancel. So now I have an x equals 6. And then on this side, again, I like to keep my variables positive, so I'm gonna take the extra step. Or is it really an extra step? So these cancel. These cancel. What do I have left? 5x equals 6. So I need to get x by itself. 5 times x, so I have to divide by x. Sorry, divide by 5. And so I get x equals 6 over 5. Alright, so now let's look at a graphical representation of the same problem we just saw. So this is obviously our absolute value expression, and then this is our 2x. And we can see we have one right here at 6 over 5. It's just past 1 right here. And then our other one's out here at 6. And that's what you're looking for when you're looking for solutions on a graph. So if you were to get the graph, this is going to be very rough. But for example, if you get this graph right here, and this is the second line, how many solutions do you have? Only one, right? This one right here. There will be few of those, but they might happen. It's coincidence, but yep, might happen. All right, let's do one more. This will be done, our last one, and then we will be out of here for this lecture. All right, so I'm going to try to get through this one a little quicker. I'm almost out of time here. All right, so let's divide by 3, divide by 3. 2x plus 1, absolute value of 2x plus 1 equals x. And then I go ahead and split these. I have 2x plus 1 equals x. It's an x. Then I have 2x plus 1 equals negative x. So for this one right here, I go ahead and subtract x, minus 1, minus 1. So that gives me x equals negative 1. And then again for here, I'll plus x, minus 1, minus 1. So I have 3x equals negative 1. So x equals negative 1/3. So now we got to check our answer. We're going to check over here. First, we're going to check for x equals negative 1. I have 3 times 2 times absolute value negative 1 plus 1 equals 3 times negative 1. 3 times absolute value negative 2 plus 1 over absolute value equals negative 3. Negative 2 plus 1 is negative 1. Absolute value of negative 1 is 1. Can 3 equal negative 3? No. Therefore, this is not a solution. And then you would check for x equals negative 1/3. However, I'm about out of time, so I hope you enjoyed it. If you need more problems, let me know, and I'll throw some more up here online. Answer the questions, and I will see you in class. Have a good day.